In this lesson, we will be finding the volume of prisms. Now, specifically, we'll be looking at the volume of a rectangular prism and the volume of a triangular prism. And so let's take a look at our formula that we'll end up using. So basically, when we're trying to find the volume, we're taking the area of the base, and we're multiplying that by the distance between the two bases, or what we call the height. So I'm going to write down distance between bases. So there's always two bases when we're dealing with a prism. And you can see that on these triangular prisms here, especially this one over here. You see how there's a triangle here, and there's another triangle exactly the same on the opposite side. And so we call this formula, we shorten this up as the area of the base, sometimes they'll use a large capital B for the area of the base, times by the height. And the height is the distance between the two bases. And it's really easy to see on this picture here because they have the hidden lines in here. So you see the area of this base we'll find, and then we're going to multiply by the distance between the two bases to give us our volume. So taking a look at this one here, if you have a cube, that means all sides are 3 inches. That means this side's 3 inches here. And I'll draw two little dashes or tick marks for the inch symbol. And the height, well, we already know that's 3 inches. Well, the distance between the two bases is 3 inches as well. So if we were to find out what the volume was, I would end up finding out this base right here. So I'm going to find out the area of this side. So I'm just going to go area equals the large base, so the area of the base, times by the distance between the two bases. Well, this is just going to be 3 times by 3. And so that's going to give me the area of the base. Now I multiply by the distance between the two bases, this distance right here. Well, this happens to be the same number, 3. And so I go ahead and multiply the base. Area for the base is 9 times by 3 gives me 27 inches to the third power. Now, I wrote A here. I should have written V. So let's go ahead and fix that real quick. So that should be V volume equals the area of the large base, or the base, times by the distance between the two bases, the height. So there is our volume. Let's take a look at the next problem here. So again, I'm trying to find the area of maybe like this front face right here. And I call that the base, the area of this base. And so it's like, typically you think of a base, it's sitting on a base, but this is just one of the bases of this three-dimensional figure. And then I multiply by the distance between those two bases, this distance right here. So let's start with our volume formula, area of the base times by the height. So our base is going to end up being 3 times by 4. Now the height is, again, this distance, the distance between the two bases. So it happens to be 2. So I go ahead and multiply these two numbers. I get 12. 12 times 2 makes 24. So it's 24 cubic feet. It's cubic because we're multiplying feet times feet times feet. 3 feet multiplied together gives me feet to the third power. Well, in the next problem, taking a look at the volume, which equals the area of the base times by the distance between the two bases, the height. So we're going to find this base right here. Right here. We're going to find the area of that. And so the area is all the stuff inside. And we go ahead and just multiply the numbers. 15 times by 6. But then we multiply by the height, or the distance between the two bases. Well, that distance is right here. Right there, because there's another base exactly the same size right on the back side that we just can't see. Well, the distance between those two bases is 6. So all we're doing is 15 times by 6 to start with, and that gives me 90, and then I do 90 times 6. Well, 9 times 6 is 54. Carry a 0, and you get 540, and this is yards to the third power. So cubic yards. So in the next problem, we're trying to find the volume of triangular prisms. Well, a triangle, remember the area for the triangle is 1/2 base times height. So that's the volume form, or the area formula that we're going to use to find the area of the base. So remember, our formula is just the same as before. All prisms are the same. You have to find the area of the base. So the area of the base times by the distance between the two bases. So when we set this one up, we're going to start with this portion right here. We're going to find the area of this. So this is going to be 6 times 5. Now there's a right angle symbol right here. So it's 1/2 6 times by 5. So we'll find that area first, and then we'll multiply by the height, which is the distance between the two bases, 4. Now how did I get that number? Well, it's the distance between the two bases right there. And that's where that number comes from. So I go ahead and multiply here. I have 6 times 5 is 30, times by 1/2 makes 15. So it's 15 times by 4. Just brought the 4 down there. And so when I multiply those numbers together, I end up with 60 centimeters to the third power, or cubic centimeters. Taking a look at our next one here, just a skinny triangular prism. But I first need to find the area of this base. So this distance right here, and then it's just all filled in here. And so what it is it's the volume equals area of the base times by the height. So the volume is going to be the area of that base first of 1/2 times by 2 times by 9. And then the height is the distance between the two bases. It's this distance right here, which is 3. So when I do that work, I end up with 2 times 9 is 18, times by 1/2 gives me 9. 9 times 3 gives me 27, so 27 inches to the third power. Well, our next one's just another type of triangle, so you can see how we've got the area of this base is what I'm going to try finding first. So this is it right here. And so the volume formula goes area of the base times by the height. And so we're going to start with our area of our triangle, 1/2 times the base, which is 10, times by 2, which is our height. And then we're going to multiply that by the distance between these two bases. Well, here's the distance between the two bases right there, 8. And so that gets multiplied by 8. And so we go ahead and multiply out these numbers. And so we have 1/2 times 20, so 20 times by 1/2. I got 20 by multiplying by these, the 10 and the 2, so that makes 10. Half of 20 is 10, times by 8 gives me 80. So 80 meters to the third power. And there's our answer. Well, the last problem is just a word problem, but they give us a picture. And I like this picture because you can really see the other base. It's the hidden lines that are in there and help you see it. So for a camping trip, Claire needs a tent that is at least 75 feet cubed of space inside. She finds a tent shaped as shown in her attic. Is the tent big enough? So let's find out. Well, we've got to find the volume of this. She needs a 75 cubic feet tent. So the volume, we start with the area of the base times by the height. Well, the base is just this triangle. We've got to find its area. So this stuff right in here. So it's just 1/2 times by 4 times by 5. Now the height, that's the distance between the two bases. So you see here's one base here, here's the other one in pink. Well, the distance between those two is 8 feet. So we've got to multiply that by 8. And so we go ahead and do some work there. So we do 4 times 5 makes 20 times by 1/2. And so when we go ahead and multiply those two numbers, half of 20 gives me 10. And then I just bring down this 8. And times by 8, that gives me 80. And so I have 80 cubic feet. Well, is this tent big enough? Well, this one's 80. The one she needs is 75. So since 80 is greater than 75 cubic feet, we would say yes, it will work out. And so that's the space inside the tent that she's got. And yes, it does work. Well, those are the types of problems that you'll see on tonight's homework. Good luck.